All right, let's jump right in. We tend to think of science as this one universal language, right? But every now and then, a new idea pops up that's so different, it's like discovering a completely new language. And to get it, you need more than a dictionary. You need a translator. So, I want you to just chew on this for a second. What if the universe's biggest secrets aren't really hidden? What if they're just being spoken in a language we haven't quite mastered yet? How would you even start to build that bridge between what we know and what we don't? And that's the real kicker. See, a radical new idea can't just live in its own little world. For it to actually be science, other people, other scientists, have to be able to understand it, to check the math, and, most critically, to see if its predictions match up with reality. Without that shared language, it's just noise. You've probably heard of the actual Rosetta Stone, right? The key that finally let us read Egyptian hieroglyphs because it had the same text in Greek, a language we already knew. Well, in science, a Rosetta Stone does the exact same thing. It maps the new, weird concepts of a theory onto the familiar ideas of science we already trust. And that's exactly what we're looking at today. This document's entire job is to be that translator. It takes these wild, new ideas from something called swirl-string theory and just systematically translates them, concept for concept, equation for equation, into the languages of general relativity and quantum physics that every physicist on the planet already speaks. So let's see how this actually works with the biggest idea of them all, gravity. I mean, this is where the translation has to be absolutely perfect. You're taking Einstein's incredible world of bent and curved spacetime and trying to map it onto this new world of swirling energy. Okay, so in the standard model of the universe, the one we all learn, gravity isn't really a force that pulls you down. It's a consequence of geometry. A huge object like the sun literally creates a dent in the fabric of spacetime, and planets are just rolling along the sides of that dent. We measure this effect with something called the gravitational potential, symbolized by phi. Now, swirl-string theory comes at this from a totally different angle. It says, forget curved space. Imagine space itself is filled with a kind of fluid-like energy. Where that fluid is swirling faster and more intensely, you get a higher swirl energy density. And SST proposes that what we feel as gravity is just that energy density. But here's the really mind-blowing part. This isn't just a vague analogy. The Rosetta Stone document lays out a precise mathematical equation. It says Einstein's gravitational potential, that good old phi, is directly, and I mean directly, equivalent to SST's swirl potential. It's a one-to-one translation. Okay, so gravity is one thing, but if you're going to call yourself a theory of everything, you can't just stop there. So this Rosetta Stone keeps going, trying to translate the entire structure of physics, describing our reality as a whole stack of interconnected layers. And the ambition here is just massive. We're not just talking about forces anymore. We're talking about translating the very nature of time, what particles actually are, and the deep symmetries that run the whole show. This is a full system reboot. And this slide just lays it all out so perfectly. It's like peeling an onion. The theory says you've got these different layers to reality. There's a layer for time, a layer for fluid dynamics, and then you get to this wild topological layer, where particles are literally knots in this cosmic fluid. And it all builds up until, at the very top, at the largest scales, Einstein's theory of gravity just emerges. I love this quote from the document because it's one of the craziest ideas in the whole thing. You ask, what's a photon, the particle of light, or a gluon, the thing that holds atoms together? In SST's language, they're unknots. They are the absolute simplest state of a swirl string, a piece of this fluid with zero topological knots in it. The most basic particles are just the simplest possible shapes. Okay, but this next part is the most important part of all, because a beautiful idea, a perfect translation, it's all completely worthless if it's wrong. So how do we know? How could we actually prove this entire dictionary is a work of fiction? This is the idea of falsifiability, and it's what separates real science from just a nice story. And that's the crucial thing here. This Rosetta Stone doesn't just give us a translation, it gives us a way to break it. The theory makes some really specific, really bold predictions that, if we ever find evidence to the contrary, would just shatter the whole framework. And we're talking about real experiments you can go out and do. The document basically says, go measure how much gravity bends light. There's a number for that called gamma. This translation requires that number to be exactly 1. If our best experiments measure it as 1.0001, the theory is in deep trouble. It also says that light traveling through a vacuum should never split based on its polarization. If our telescopes ever see that happen, the model is wrong. And finally, it flat out forbids some weird types of gravitational waves. If our detectors ever hear those forbidden ripples, the translation is proven false. Game over. So as we start to wrap this up, let's just zoom out and ask the big question. Why does a document like this even matter? What's the real point of making a Rosetta Stone for a brand new scientific idea? It's really easy to see this as a fight, a new challenger trying to knock out the reigning champion. But honestly, that's not the point at all. The goal isn't to build a wall around a new idea and just shout at everybody that you're right. It's about building a bridge. It's an invitation. It says to the entire scientific world, hey, we've got this new idea. You don't have to learn our weird language from scratch. Here's the guide. Take your own tools, use your own methods, and check our work. In fact, please try to break it. That is how science is supposed to work. And hey, don't take my word for it. The paper's own abstract says it best. The whole point is so the ideas can be read, checked, and compared. It's about opening a conversation, starting a debate, and allowing for rigorous testing. It's about making a new idea part of the scientific community, not separate from it. And that kind of leaves us with one last thing to think about: swirl-string theory. It might be right, it might be wrong. Only time and experiments are going to tell us that. But the effort to translate it is so important. And it really makes you wonder, doesn't it? What other huge, game-changing ideas are out there right now, just waiting for someone to build the right bridge, to create that Rosetta Stone that finally lets the rest of us see what they're seeing?